Welcome to the physics scenario classes. To discuss a question on mathematical physics that was asked in GATE 2010. The question is related with the differential equation. The question says the solution of the differential equation for yt, y as a function of time, given by d2y upon dt2 minus y equals 2 cos hyperbolic t subject to initial conditions y at 0, that is t equals 0, it is 0, and first derivative of y with respect to t at t equals 0 is again 0, is option A half cos hyperbolic t plus t sin hyperbolic t, option B minus sin hyperbolic t plus t cos hyperbolic t, C t cos hyperbolic t, and D t sin hyperbolic t. Let us see the equation. It is d2y upon dt2, that is second derivative of y with respect to t, minus y equals 2 cos hyperbolic t. This is a non-homogeneous equation. In order to solve it, first of all, we should try to find complementary solution of this equation. So, the complementary equation of this may be written as d2y upon dt2 minus y equals 0. In D operator, it may be written as d2 minus 1 y equals 0. Let y equals e to the power mt. Then y prime equals m e raised to mt and y double prime equals m square e raised to mt. Thus we have m square minus 1 e raised to mt equals 0. From this we have m square minus 1 equals 0, because e raised to mt can't be 0. So we have m plus 1 multiplied by m minus 1 the bracket equals 0. So we have two values of m, it is minus 1 and plus 1. So solution of this complementary equation, which is homogeneous in nature, may be written as y equals c1 e raised to mt. This is the solution. So it is minus t, minus 1 multiplied by t, minus t, plus c2 e raised to plus 1 multiplied by t, it is t. So this is the complementary solution of this equation. Now, before proceeding to find the complete solution and then applying initial conditions, we have to find particular solution, and for that we should write like that. Equals one upon d square minus 1 2 cos hyperbolic t. How we have obtained it? This is d square minus 1y equals 2 cos hyperbolic t. So y equals 1 upon d square minus 1 2 cos hyperbolic t. Now what is cos hyperbolic t? So it is cos hyperbolic t is e raised to t plus e raised to minus t divided by 2. So twice of cos hyperbolic t, it is e raised to t plus e raised to minus t under bracket. Now to solve it, 1 upon d square minus 1 may be written as 1 upon d plus 1 and d minus 1, just like we do it in algebra. And here it is e raised to t plus e raised to minus t. Now bifurcate it, that is 1 upon d plus 1 d minus 1 e raised to t plus 1 upon d plus 1 the bracket d minus 1 multiplied by another bracket and e raised to minus t. Now let's write it like this: 1 upon d minus 1 and 1 upon d plus 1 e to the power t plus 1 upon d plus 1 1 upon d minus 1 e raised to minus t. Now 1 upon d plus 1 e raised to t, what can be written? 1 upon d minus 1 1 upon d plus 1 e raised to t plus 1 upon d plus 1 under bracket 1 upon d minus 1 e raised to minus t. Now there is a formula for operator techniques that says that 1 upon d minus m, if it is the situation and the function is phi, then it is e to the power mt under bracket integral e to the power minus mt multiplied by function and integrated with respect to variable t. So applying it, we have 1 upon d minus 1, and here it is, compare it, in place of m there should be minus 1. So we have the formula like e raised to just place minus 1 in place of sorry, minus 1 in place of m. So we have minus t integral e raised to t, and the function is phi. In place of phi it is e raised to t, so e raised to t dt. And here the next term we have, here in place of m we have 1, so it's e raised to t integral e raised to minus t, and in place of phi we have e raised to minus t dt. Now it is 1 upon d minus 1 e raised to minus t, and it is integral twice of t dt plus 1 upon d plus 1 e raised to t integral e raised to minus 2t dt. Now this is 1 upon d minus 1, we have e raised to minus t, and this will be e raised to twice of t divided by 2, and this is 1 upon d plus 1 e raised to t, and this is e raised to minus twice of t divided by minus 2. So we have 1 upon d minus 1 e raised to t upon 2, and the next term is, second term is, it is 1 upon d plus 1 e raised to minus t multiplied by minus 2. It is half, take common half from both terms, and it is 1 upon d minus 1 of e raised to t minus 1 upon d plus 1 of e raised to minus t. Again we should apply this, and we have half, here m equals 1, so we have e raised to t integral e raised to minus t, and the function is e raised to t, this is the function dt, minus, this is minus. Now this term, here m equals minus 1, so we have to write e raised to minus t integral e raised to t, and the term function is e raised to minus t dt. This is half e raised to t, and this is what? This is e raised to minus t plus t, that is e raised to 0, it means 1. Integral 1 dt, it is t, so it is t minus e raised to minus t, and here again it is t. Take common t from both terms, we get t upon 2 e raised to t minus e raised to minus t. This may be written as t common e raised to t minus e raised to minus t upon 2. What is this? This is nothing but sine hyperbolic t. So t sine hyperbolic t. This is the particular solution. So the complete solution may be written as y equals c1 e raised to minus t plus c2 e raised to t plus t sine st. Suppose this is equation 1. Now we have to apply the boundary conditions. What is the boundary conditions? It is y at t equals 0, 0 and first derivative of y with respect to t, y prime at t equals 0 or equals 0. So when we apply the first condition in equation 1, we have 0 equals c1 plus c2. Set equation 2. And now differentiate y with respect to t to apply the second boundary condition. D by dt of y equals minus c1 e raised to minus t plus c2 e raised to t plus this is u times v. So t differentiation of this with respect to t sin st, it is cos st plus now differentiation of t with respect to t, it is 1 multiplied by this sin st. Now applying the second boundary condition, we have at t equals 0, it is minus c1 plus c2. At t equals 0, it is 0 because 0 multiplied by 1, it is 0, and at t equals 0 sin st is also equal to 0. So both these terms vanishes and we have this. So this is equation 3. Now bus summing 2 and 3, we get 2c2 equals 0, that is c2 equals 0. Using this in 2, we get c1 equals 0. Applying these two values in 1, we have y equals, first term is 0 because c1 is 0, second term is 0 because c2 is 0. We have y equals t sin st. So this is the required answer of this question. So option D is the correct answer. Thank you.